part of what I'll talk about today is actually dealing with technical malfunctions, which are happening all the time. The class that I'm going to concentrate on is economic computation. And students are learning a lot of skills, a lot of technical skills in that class as they're practicing every day. And lo and behold, even the professor makes mistakes, or I should say, has to learn things that maybe he didn't know before the class started. Or sometimes he's just sort of, has bad memory. That's okay too. We're continually having to deal with unexpected events, and especially when you're learning something new at the front of the field, this is actually not a problem. Students need to see that you're not perfect. Students need to see that you have to deal with all the same problems that they have to deal with. Okay, I'll get started, and hopefully y'all can see the slides in the background. It's okay, you don't really need to see the slides, and hopefully that's true about most PowerPoints that we're watching. It's really just a heuristic to keep track of where we're at the top. So today we're going to be talking about learning by doing in-class workshops for high-speed skill development. Okay. So when I first started teaching, I was accustomed to your standard class structure, which is the professor gets up in front of the room, talks for an hour, you're not sure what you need to know, and then you get tested on it. Right? This is more or less the frame that most students, I think, are operating under. The professors, of course, are doing their best job to convey explicitly and exactly whatever it is that the student needs to know. This is especially true. Like if you take a calculus course, there's really no getting around that sort of thing, right? So have somebody raising their hand in the room? Yes. But there are a lot of courses where not only is this not necessary, but it's actually going to inhibit what you're trying to teach the students. Okay? And especially if you're trying to push the students to the edge of a field to try to see what they can explore, and that edge requires a lot of different skills. So in this case, we're going to talk about computation. That requires a number of different skills, including being able to program, right? Basic programming, right? Knowing a little bit of statistics, and then being able to apply economic theory. And the most important thing, just having that persistence. Right? Not feeling discouraged if you feel like you've made a mistake. Yeah. So why change format? Well, there's a nice incentive here. I've up here Glassdoor returns for data scientists. And you can see median pay of data analysts, scientists, quantitative analysts. Relatively high median pays, even for just data analysts, 77,000 a year. This is starting 0 to 1. For data scientists, 0 to 1 years of experience. You can see it's a wide range, but that bottom is not bad, right? If you're teaching students, you think they're going to be in just the bottom 20% of the pay scale, that's not a bad starting wage getting out. I tell my students when I teach this course, if you take it seriously and you make it your own, your pay is going to go up 10K a year starting, right? And that doesn't sound bad if you're a student. Hopefully that motivates them. So there is this large incentive to get students prepared for something that maybe they haven't been prepared for in their career. Okay, so we got to think about, well, how do we do that? That's what we'll be going through today. So when we talk about data, really data, anything, right? But data science is sort of what's talked about, big data, these sorts of things. When you want to get students prepared for that, this is a tough job. Why? Again, because they need programming skills. So you have computer science on the top left side. Now, when my students enter the class, I say, 1, I am not a computer scientist, and 2, I understand that neither are you. But you have to have some programming ability, just basic programming skills, right? I'm not building computer scientists. I'm building people that can use basic skills to build interesting projects, to gain interesting insights. Likewise, I'm an economist. I'm not a statistician, but I have to know basic statistics to do my job. Likewise for the students, and it's not that difficult of statistics to know. Okay, so there's a lot of sort of entry-level things that they need to realize that they're going to be referencing. Likewise, and on the economic side, which is usually you think of as being closer to statistics and definitely into the business realm, research realm. Right, these are the insights that people who've only been trained in math or stats or computer science probably are not going to be familiar with. Okay, so that's a lot of skills to get to students very quickly. It seems intimidating. Students want a job that's fulfilling, that's enriching, that enriches their bank account as well. How do we get all this in one class? And this is more or less was the motivation of my developing a course that is largely learning by doing, or in other words, it's entirely workshop based. Okay, so you show up at the class, you don't know much getting in. Maybe you've taken a statistics class, maybe you've taken a computer science class. I do my best to assume you have as little of knowledge of that as possible, and then say, okay, well, what can we do, and how can this still be useful to you? Yeah. So when you hear the word data science, most people don't know what that means. Here's one way of thinking about it. You have projects, they have data here. I think this would be better if this is a project, but you have a project, and you are working furiously to bring together all these different ideas, or maybe all these different libraries. I use Python in my class when I'm teaching this. And realize how to use them. So that's a lot of skills, right? Usually in a single class, for example, a standard econometrics class uses a program called Stata, right? Stata is going to run regressions for you. It's going to have a visualization library, but your ability to use those things are going to be generally limited because the expectation, really the program has a particular focus. The nice thing about working in Python is each individual library is like a program. So instead of just working one in-the-box program, you have all these different pieces that you can mix and match: statistics libraries, visualizations libraries, machine learning libraries, which is just statistics with AI. And the question is, how do you make this useful? In my class, I really emphasize the data visualization aspect because most students aren't going to be familiar, but they can get a lot of value by visualizing their data. This is something that's generally underemphasized in econometrics courses. Yeah, so help students get to know their data. Now, what's the problem? The problem is when I get them started, like I said, they're probably not going to know much, and they look and they see this word data science, and they feel like this person at the bottom of the ladder. They've learned economic theory, and they start looking. You look for job advertisements. And job advertisements in economics will often say something like, 2 to 4 years of experience with R or with Python or with such and such program. Jobs that students are just getting out of school. Maybe they've taken a class in those. Probably they haven't taken a class in what's being expected. And when they start searching for a job, they say, oh, look, all of these jobs over here that I thought I might be able to have access to are actually off limits now. Okay? And so, again, if you a sort of generalist class like this can bring in a lot of skills and open many opportunities for the student, both to be creative and also to enrich themselves. Yeah. So how do we do this? It seems like a lot. It is a lot. And my expectations as a professor are different in this class than they'd be when I'm teaching my intermediate macroeconomics course. I teach intermediate macroeconomics. It's kind of like that calculus comparison. There are certain things the students have to know, and there's no getting around it. With computational economics, this isn't so much the case. This is more of a buffet of different skills that are going to help them get employment and help them work on projects. Also will help them if they would like to go to graduate school, because these are the skills that professors are looking for when they look for help from students. So how do you get it? Well, you don't tell them, you don't prove it to them, right? But rather you give them many, many, many examples, many iterations. And think about this, right? We have across the course of a semester about 16 weeks, meet twice a week for 75 minutes. Right? That's a lot of time to be getting a skill set. So what do we do? Well, this is day one. Students show up and they have to build a really basic program. So this is in a Jupyter notebook that I use for the course, and I teach students to build exactly these sorts of things. So you can write a paragraph, add some code, have the code do something for you. Again, it's not difficult to imagine how this worked out here. So here's our first program we do. This is the first program in basically every programming book that you find. It's called Hello World. The first thing you tell the computer to do using the language is to print some sort of statement, okay? And here we're printing Hello World. That's just some string. This is text. String is a text. That's a data type. And you can see underneath here, you print out Hello World. Well, that doesn't seem too intimidating. Any student can write that out. And what we find is being a good programmer, being a good data scientist or data analyst is really just being able to make use of a large variety of skills, okay? It's that simple. Many, many, many different skills, the first of which is going to be print. And we'll keep using that print skill. So every project is going to build on the previous project. We're just going to build this thing out, build it out, build it out, build it out. Okay? So pretty quickly, it takes, I would say, about 3 or 4 weeks in the course to get the students up and running with the sufficient amount of skills to get them comfortable with data and data structures. Okay? They'll be by no means masters of it at that point. But the good thing is, one, not only are we meeting every day in class and working on these things, but every 1 to 2 weeks, students have a homework that they have to complete. So they practiced in class, they feel comfortable from what they worked on in class, then they go home and then they have to answer some problems, okay? So by week 5, they're comfortable enough that they can build a program that looks like this. Okay? So this is a program that one plots a line and then generates data stochastically around the line. Okay? So here's our mean, the line is the mean, and you have a random number generator that you can, I can't remember if I used a uniform or a normal distribution here, but you can see in the least, at least the average error is going to be 0 here around that line. So students really like this because these are the sorts of examples that when you're in econometrics class, you see in your textbook. They'll say something like, the world is composed of data generating processes. Okay? And what they mean is data is generated by some normal distribution defined by a mean that can change depending on other variables, right? And they see this, and suddenly all these all of the examples in books that they've seen like this suddenly make sense. And two, if they've taken econometrics, or later in the class they'll see, in econometrics, we're just doing the inverse of this. We're taking a bunch of data points and trying to estimate a line. Okay? Really simple concept, and you can see here, we can build out not only the data, but the visualization in, let's see, that's about 5 lines of code plus, what is that, about 9 lines of code? And then you call the function. So definitely in less than 20 lines of code, you can build this visualization, which includes building all of the data along with it, okay? By this point, students are comfortable building functions, because notice here, I've housed this data in a function. You have some defined function, plot line, some defined function, random data with line. Put those together. In the course of the project, they build these out piece by piece by piece. This is just the final result, and you get this. Okay. Well, it's not very difficult once students know that. The next part of the lecture, they're going to generate random data, and they're going to create a Monte Carlo simulation. Okay. This is a simulation of data using a normal distribution. You're just pulling random pieces of data. You're summing them together, and you get this line. Okay, this is a really common method. Of course, statisticians use it, economists use this. In finance, you use this, and I'll show you by the end. You can use it in estimating expected returns from some portfolios, investment portfolios. Yeah. Ultimately, the students end up creating this, add a for loop to what we just did, and now we have 1,000 simulations of the Monte Carlo simulation. All these different lines sort of plotted together, give you something that looks aesthetically appealing, okay? So this is a project you get to by week 5. I couldn't teach theoretically. If I forced my students to understand theoretically every single part of the application here, they would feel overwhelmed. But what students don't realize is it's a lot easier to use a concept than to prove a concept, okay? And my job in this class is not to prove all of the concepts. My job in this class is to say, as an economist, how can you use these concepts? And the great thing is every project we do in class, those are notes. And they can go back whenever they're building a project, say, hey, I like that visualization that we used in week 5. How did we build that? I'm going to rebuild it and think about how I can apply it to my current project. Yeah. Here's another example, and I'll go through a couple more of these. This is the next project. So after the last one I showed you, the final part of the project that we do is build this distribution of stock returns. We download stock data, we look at daily percent change in the stock prices, and we compare distributions of stock prices. Okay? Not many lines of code here. You don't need to master the code at this moment or anything like that. You can see, again, about 15 lines of code. And the result is this. And so we can see here we have different distributions of returns for different stocks. You can see Microsoft is the one that's closest to the mean with the least variance, or you can say lowest standard deviation. Okay, that's the blue line at top. Whereas Tesla obviously has more volatile returns. That's going to have these fatter tails, that pink here. Okay? So that's nice. We can compare. We can talk about things like efficient markets hypothesis when we look at this. Okay, which is assumptions that you make in finance. I don't need to teach you efficient markets hypothesis today, but anytime you talk about data, you can bring in so many different concepts that are fitting with the economic data that you're looking at. In the end, you have a nice result. Again, if students like this, and a lot of my students really like the idea of using Python for finance, they'll draw from this lesson very, very commonly. Okay. So here's another, and again, notice part of what we're doing here is we're making what they're learning aesthetically appealing. That's a nice sort of, it's not the main point, but it certainly doesn't hurt. I've had many students that come through my course and they say, I never knew how to investigate my data before. It just, I thought about data in terms of tabular data in a table. And what we do is we go through each of these different examples. We're getting students accustomed with all of this code, with all these different functions. I'm really just teaching them how to get familiar with their data. Okay? And when they start investigating, they can ask the question, well, which of the tools that I learned so far is going to help me in the quest of figuring out what my data is telling me, you know, before I even get to things like economic regressions. Okay, before I even start using statistics, I can look at the data many, many different ways. Okay, and so here what I've done is adding a third dimension, this color. You can kind of get an idea about how data correlates. Generally, there seems to be an upward and rightward correlation of these two variables that we're looking at here. Again, which economic variables they are at the moment isn't particularly important. What's important is that you're giving students intuitive ways, and this really is the theme that I hope you're hearing here. Intuitive ways to approach their data. You're teaching them to do it in a manner that's not super costly. Again, this is about 15 lines of code, 20 if you include the bottom 4. Once you've spent, 10 or 15 hours in class doing this, that doesn't look very intimidating. Okay, just a couple more examples, but I'll go through here. Here's the last one we'll look at. Again, visualizing is very powerful, and students feel empowered when they see this. Here is the unemployment rate across the country relative to February 2020. Remember what happened April 2020? So here's a nice example of, again, using data to show students how they can convey things without even getting very complicated. Haven't even gotten very complicated yet, okay? Just practice, 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 show students these kinds of examples. And you can see here, unemployment obviously went off the charts, max of 30% change downward in Michigan, in many counties, right? That's frightening. And examples like these really get students involved thinking, okay, well, what am I going to do with my project? We've been doing all these projects. What am I going to do with my project? I'll go through here. We've seen, I think, enough examples at this point. But this is the last bit here. Finance students, right? Trying to get something for everybody in the class. We have a lot of finance students. We use that Monte Carlo simulation to build expected returns. And you can compare expected returns versus observed returns versus the whole space of potentially predicted returns. Again, by the end of the class, they're able to build this. All right, so enough about what you build. What's the nature of leading a workshop? Right? What is the nature of showing students that a world that is absolutely massive, trying to compact it down into a single semester, getting them ready to maybe go out into the workplace, getting them ready to go, maybe they want to pursue after they get their economics degree, a degree in machine learning. Maybe they want to move into the field of data. Maybe they want to just take this with them and do a graduate degree in economics, right? Well, no matter who you are, This is your best friend when you're dealing with these sorts of things. Students don't know that when they get in my class, right? We teach students something and there's so much that we can teach them. And then they say, I couldn't find it in the book, or there's this question, I couldn't find the answer. And what I want my students to see after they take my classes, no matter what you're doing, the first thing you should probably do is Google it just to get an idea about what's going on, okay? We teach students a class is contained, it's this box, and within that box is the textbook and the lecture slides. And to limit all of your learning to the textbook and the lecture slides, do not step outside of those bounds. Right? But obviously this isn't true in the real world. Somebody's going to give you a single lesson. Maybe they spend an hour with you, they give you an idea, and then they want to develop the project. Well, of course, they're not even going to give you a bibliography. Maybe they will if they're nice. But ultimately, it's going to be your responsibility. We have the most powerful tool in human history right at our fingertips, right? Now, the way I show this in class is when I have errors, right? I have errors all the time. I'm building a program. You saw 20 lines. You run and something shows up. Maybe I know the response, the right response, maybe I don't. No matter what, an error is always a chance to teach students how to self-teach. This is the big thing, okay? So you're running the program, 20 lines of code, you see where the error is, but you can't even remember what it's supposed to be. So what do? Well, let's copy and paste the error text into Google because there are many, many millions of Python users out there. The same is going to be true for R, many other programming languages and architectures. Yeah. Place that in there, maybe add a keyword. Yeah. Ultimately, the code ends up looking like this, maybe, especially when you're first learning. Yeah. So you search, you find the answer. You find a beautiful function on Stack Overflow, which is the site that has all the answers to your coding problems. It's an open source community, basically. Community members can contribute and ask questions, okay? And students need to be okay at first understanding that this is what their projects are going to look like. Now, I want them to be able to explain what they're doing, and if they can't explain something, they should at least be honest about the fact that they can't explain it. But again, my job is to teach students how to build projects in economics, give them the tools, and ultimately the way I judge them is not to say, did you get every aspect perfectly like I taught you, but rather to say, were you able to build something of value with what I taught you? Projects are going to end up looking like this, right? At first, or at least a lot of them, a lot of projects are actually really impressive, surprisingly impressive, but it's okay, right? If the first project ends up looking like this, it's a start. Yeah. So what do? Well, I see a GitLab t-shirt in the room here. My students are required, once they've gone through the workshops, they've been building projects every week. Well, guess how they're going to advertise themselves when they're done with the class. They have a GitHub. And all of the work that they do, they're going to upload to the GitHub. And I tell my students, your resume, you have a resume, but what you don't realize is after you take this class, your resume is going to be the link to your GitHub that you put at the top. That's your resume. Your employer, your future employer is going to click your project, they're going to see what you did, and they're going to say, can you do that for me? Yeah. Now here I have I'm not showing the students project repository, but I have a project repository for a paper, for data for a paper that I've used, right? It's the same concept, right? From the GitHub website, you can navigate and you can see the notebook just like you created. So it looks like this. So that means when students are doing their homework and when students are building projects specifically for your class, they're not just building for a grade, at least ideally they're not. If they actually care about what they're doing or using this in the future, they recognize that whatever they do, that's going to be open and available to be seen on GitHub. Yeah? They do a good job. So why all this? Why do things differently? Well, you can see here, by taking a different approach, we get students used to the idea of persistence. Okay? Every single day, they have to show up and they have to work. Every single day, if they have a project, they need to make a little bit of progress, a little bit of progress, a little bit more every day. It's consistency. It's not something you just study for the night before an exam. Okay? So they're learning implicitly in this a life skill. Why? Because every week or every other week, they have to build a project. Right? A few times throughout the class, and definitely by the end, they have to work on a major project. Yeah? and this project is their own. They have to invent it. They have to write about it. And they can only get that by working every day. Well, this is fundamental. This sort of purpose, of course, is concomitant with what we call Eudaimonia, okay, which is sort of flourishing. Have you ever heard of that word flourishing? Very big at the Ivy League, especially at Harvard. They started in the philosophy departments, PPE. They started talking about this idea, this concept of flourishing. I think in your teaching, it's nice to get students to fully 100% master a concept. But at the end of the day, we have to have an eye on the students and what can they work on that connects with their interests and with their hope for the future. You know, at the beginning of the class, I make the students answer a few questions and I say, what do you expect from this class? What do you want to get out of this class? And how is this class going to help you with your plans in the future? Okay? Answer those questions for me. Why? Because I want you to be bought in so that every day you show up, you work hard, you know how difficult it is from day one, but you're willing to because you're interested in flourishing. Okay? That's simple. But of course, this doesn't hurt either. All right, so that's it for the presentation. Happy to answer any questions you may have.
How much do you have students work in, as 2s or 3s during these lab sessions?
Yeah, they're all present, and I encourage them to talk to one another and sit next to one another, and usually that's what they do. I give them time. So one thing I didn't talk about was in the workshops, it's not just me going for an hour and 15 minutes. I build out a few codes. I generate a result, and I say, get that part done. I'll walk around the room, I'll talk to students, and students will talk to each other. Usually they figure out 1 or 2 people that they can talk to, they feel comfortable with. Yeah. I think that's really important as well in helping them get comfortable, is making them feel like the purpose of this time is to enable them, right? Not to give them so much that they can't keep up with, right? On the projects, they have to turn in their own. They can't work, they can't turn in one project for more than one person. In other classes where they actually have to type out things, they actually have to write a written response. It's not just about, building code. I use the same kind of strategy and I allow them to work in teams. But in this class, because they're putting up their own portfolio, it's all about their skill, what they can do, advertising for them. It has to be individualized. So I can't see online, yeah.
Do they learn Git also, how to collaborate in different branches?
That's right. So they get basic Git. I don't make it too complicated for them. I would, there are a lot of things to learn. Students that I know who went on after the class, because they knew Git, they could learn, those things like cooperating, working with different branches. I make them use the command line, be able to upload and then, clone anything that they need like that. That seems to do pretty well for them, but that's enough problems during the semester with Git for me in helping them out.